Welcome again to Critical Thinking. As promised, today we are going to go deeper into what does it mean to obey the laws of thinking, of reason in general. What are the logical principles? First of all, I would like to introduce some concepts: logical form, logical principles, logical correctness. And this is very important because otherwise it is difficult to explain what are the laws of correct reasoning. Now, let us take as examples the following sentences. Metals are good conductors of electricity. The insects are quadrupeds. The number of stars in our galaxy is even. The chair has a rectangular form. Any isosceles triangle has two equal angles. I chose these sentences because they come from different places, and we have different instruments that we may use to determine whether they are true or false. For instance, we have to have knowledge related to physics to know if the sentence metals are good conductors of electricity is true or false. Just as I explained in our introduction, in our brief introduction, it is not enough to have knowledge about logical validity. That is how to use this sentence to build a correct, a sound, a valid argument. It is also important to have information coming from different sciences to know whether this sentence is true or false. Usually, it is very important also to know that in logic, we use claims that have a truth value and a truth value that we can establish. Now, about the truth, you have to know that a number of treatises have been written. A lot of philosophers, intellectuals, thinkers, tried to offer a definition of the truth. It is a truth we can establish if a sentence is true or false, if we look around us, inspect the reality and see whether the sentence is in accordance with our perception. But as we know, perception can easily be misleading. So what does perception mean? Isn't our perception influencing the very reality we are observing? This is a very, very complex subject, but for the time being, we say that we use in logic sentences that have a truth value. What do you mean? In general, do we use sentences that do not have a truth value? Well, think about the difference between these sentences that I just laid out here and the sentence, I declare the session open, or I am starting the course, or I pronounce you husband and wife. These are a different type of sentences that uttered in the right social context change that social context and attributes to people probably new roles, or change what I said, the social reality. And it is the context, not the meaning of the word or the correspondence with reality, that offers them the power to basically change the social reality. This is another very interesting and important topic to be discussed, but it is outside the scope of our course. Bear in mind that here we are usually dealing with sentences or claims that have a truth value. Now, here, the insects are quadrupeds. Here you look at insects and you see, are all insects quadruples? You may think that this is a false sentence, since not all of them are quadruples, isn't it? You have insects that have more than 4 legs. Now, the number of stars in our galaxy is even. Since the universe is infinite, this may have a truth value, but it is very difficult to determine what that truth value is, or the place where we are, the stage that we reached in our knowledge as humanity hasn't allowed us to determine yet if this is a true or false claim. The chair has a rectangular form. Well, it depends. For this, you have to see what is the chair that you're referring to and to inspect the reality. This is a very simple claim, and its truth value can, of course, be easily determined just by looking at the particular chair the sentence is referring to. And any isosceles triangle has two equal angles. Well, you need a little bit of knowledge of geometry to determine its truth value. It is not a sentence whose truth value can be determined so easy, but it can be deduced from other information that you may have if you study mathematics. Now, it is also important to note here that there is a difference between the logical subject, the logical predicate, and the subject and predicate that you used to learn in logic. Usually, the subject is that term. It can be complex and it may contain several words, but it is the one we are referring to and ascribing properties to. Any isosceles triangle here is the subject, or the number of stars in our galaxy. Here you see that you have several words, and usually in grammar, especially the ones, the Romanian students that studied a lot of this in their Romanian classes, have the tools and the ability to analyze each and every word, but this, the number of stars in our galaxy, is actually the logical subject, and is even, also you have here in grammar a complex analysis of this, but in logic, this is the logical predicate. And it is important to notice here that usually in logic we have objects and the properties ascribed to them. We very rarely have processes in first order logic. And for those of you who are interested, I will further develop an answer to this question because I think it's very important. For the time being, you have to understand that we have the logical subject that may be expressed by several words, but it is usually an object, and the logical predicate is the property that we ascribe to that particular subject. Now, we have basically three logical forms. A form, what is a logical form, is that abstract structure that usually guides our reasoning. And we have three logical forms: notions or terms, sentences or claims, and arguments. These are the basic tools that we use in logic, and we will study the terms, the relations between terms. We will study sentences, relations between sentences, and of course, with those sentences, we form the arguments. So we start with the simplest logical form, which is the term or the notion. Then with those notions and logical terms, we form sentences, and with sentences, we form arguments. Now, there are two types of arguments and two types of reasoning: deductive reasoning. I will give you here an example that is one of the most used examples in logic. All humans are mortals. Socrates is a human. Socrates is mortal. We start with a generalization: all humans are mortals, and then we deduct from that that each element in the class of humans is also mortal. And usually in this type of reasoning, the conclusion says less than the premises. Usually in deductive reasoning, we start with a more general premises and we extract from that the conclusion. We deduct from that the conclusion. Now, we may also have in logic, and this is also important, inductive arguments. Take the following example. The goats are herbivorous, the cows are herbivorous, the gazelles are herbivorous, the antelopes are herbivorous, the goats, the cows, the gazelles, and the antelopes have horns. Conclusion. All the animals that have horns are herbivorous. As I told you, what do you see here? Usually in inductive reasoning, the conclusion says more than the premise. Usually you have a set of premises. You see that there is a common trait that all those elements have here. The animals that have horns. So you may infer that you have the situation where all the animals that have horns are herbivorous. That is, the conclusion says more. You expand from particular instances to a more general conclusion. So in deductive reasoning, the conclusion is not does not generalize from particular instances. Is it quite the opposite? You start with a general premise and you deduct from it a more particular conclusion, if I may say so, because it is not is not particular in a sense that from a general premise you deduct something that says less than the premise, and from where you have premises and you see that the same thing repeats itself, you may infer that you may have a generalization, but you have to be very careful with that, because the conclusion, because it says more, is not as or should I say, as certain, if I may say so, as in the case of deductive reasoning. Deductive reasoning is safe, so to speak, but deductive reasoning does not allow us to expand the knowledge. Inductive reasoning does not produce the same kind of certain conclusions. They are very probable, but they are not certain. And this is important to keep in mind. The logical principles. As I told you, we have a few: the identity principle, the non-contradiction principle, the tertium non datum principle, or the excluded middle, the principle of sufficient reason. Now, the identity principle, in any discussion, prove the notion that we use have to have the same meaning. The mouse is eating the paper. The mouse is a common noun, so common noun is eating the paper. Now, what is the problem here? The problem is that we use the same term, mouse, with two different meanings, and thus the ridiculous conclusion. The non-contradiction principle. There is no way for two sentences, one of which affirms and one of which denies, implicit or explicit, the same thing about the same object, to be both simultaneously true. Let us explain. Let us consider property 1 and property P and property P1. Let us consider the property P that affirms something. Say the pencil is yellow, right? So you have the logical subject, pencil, and the logical predicate ascribing that property. The pencil is yellow. Is yellow is the predicate. So this one affirms something about property P1. Then about property P. Then P1 denies it, says well, the pencil is not yellow. You have to understand that these two cannot be true at the same time, that cannot be simultaneously true. It is important to know that maybe the pen changed its color in time, but this is important to place an emphasis on simultaneously, because of course things may change, but when you utter this sentence at that particular moment, the two sentences, the pencil is yellow, the pencil is red or green, cannot be true. Now, another important principle is the principle of the excluded middle, tertium non datur in Latin. For any sentence, at the same time when considering the same aspects, there are but two possibilities. The sentence is either accepted or rejected in a system of sentences, a third possibility being excluded. A sentence can be accepted in a system of sentences, say religion, for a religious person, but rejected in another one, say science. But the sentence cannot be both accepted and rejected in the same system of sentences. So this is also very important to keep in mind, because usually when you discuss with people that have different systems of beliefs, you have to understand that it is very difficult if you don't have common meanings of the terms. You see that this seems very, very easy, but when you think about a conflict, say on very sensitive topics like abortions with a person who's religious, probably you're not, or the other way around, you're religious, but the other one is an atheist, then it is very difficult to find a common understanding, because you have different systems of sentences that you accept as true. Now, it is important here to notice that it is not the principle of bivalence, saying that any sentence must be either true or false, right? So it is not to say that you have a unique system of sentences that you consider true or false, and any kind of sentence might be either accepted or rejected. There are systems of sentences, there are systems of beliefs, there are people who with different types of beliefs, but what this principle requires from them is for them to be coherent and consistent. And if they accept a sentence as true in their system of beliefs, they cannot at a later point reject it or say it is false. So this is a principle that requires of us to be coherent in our system of beliefs. If we have a system of belief, we have to stick to it, right? It is not to say that everybody must accept the same set of sentences as being true. We may, and each and every one of us may have different systems of beliefs, but once you say you have that system, you cannot accept at a point a certain sentence as true and then reject it. And this is important to keep in mind. Now, the principle of sufficient reason. For any sentences that we accept, we must have a reason. This is very, very important, because that requires of us to base our conclusions, our assertions, or on certain reasons. And there are 4 types of reasons: necessary but not sufficient, the one that I just explained. In order to be a rational being, it is necessary to know logic, but not sufficient. Sufficient but not necessary, necessary and sufficient, not necessary and not sufficient. Let us think of a few examples here. I will give you some examples, and during the seminar, we will try to find a number of other examples. For instance, let us think of another example of necessary but not sufficient reason. For instance, I studied, therefore I will get an A. This is, I think, very easy to see that it is necessary to study to get a very good grade, but there may be other things involved. For instance, you have to be able to do your best to concentrate during the exam. You, as students of all people, should know that studying, unfortunately, is not enough to get an A. Now, let us think of an example of necessary and sufficient reason. Saul Bellow and Philip Roth are friends. Therefore, Saul Bellow and Philip Roth are contemporaries. So if they are friends, we can deduct easily that they are contemporaries. Now, the other way around, if we invert the sentence and we say that Saul Bellow and Philip Roth are contemporaries, therefore they are friends. What kind of reason is this? This is sufficient but not necessary. So if they are contemporaries, it is not necessary that they are friends. Or if you say something like, I wear my red socks today, therefore I got an A in logic, this is not necessary nor sufficient. This is just an expression of irrationality and of making connections that have this is not a reason that you may consider as rational because it is not necessary nor sufficient. Now, coming back to this very, very interesting question of logical correctness and validity. This is a tricky part, and I want to put a special emphasis on this. The validity or logical correctness referred to the logical forms that obey the principle of correct reasoning, the identity principle, the non-contradiction principle, the principle of excluded middle, or the sufficient reasoning principle. But as I explained, unfortunately, you may have validity, but not truth. What do I mean by that? Let us go back to the example that we discussed in our introductory course. All state authorities lie to the public. Raed Arafat is representing a state authority, therefore Raed Arafat lies to the public. We saw this during the pandemic in Romania being uttered time and again. Now, we may have valid arguments based on flawed premises. The logical validity is independent of the truth of the sentences that we use. The logical correctness is a necessary yet not sufficient condition for the truth of the conclusion. So the truth is dependent on the logical correctness. What do we mean? Well, we have to have logical correctness. This is necessary, but it is not enough. So in order to have a true conclusion, we have to have the logical condition. The logical forms and operations have to be valid. And also what the logicians called material condition. And now we are in the position to say that logic helps us with the logical conditions. It offers us the logical principles and rules by which we can form valid arguments. The material conditions, way to establish whether the sentence premise is true or false. Well, we need different branches of science to establish that. Also, what does logic validity means? It is impossible for the premises to be true and the conclusion false. Logic validity says, and you have to imagine it like some sort of corridor, meaning that if you start from the right place, it is impossible not to reach the right destination, right? It is impossible to start with a true premise, to have a valid argument, and not to reach a true conclusion. So it is like, as I told you, you could imagine it as a corridor that is getting you from a good place, in inverted commas, that is getting you from true premises to true conclusions. This is how you should understand the relation between truth and validity. It is very, very important to bear this in mind because, as I explained, there are people who put a great emphasis on logic, thinking that it can solve everything. No, it can solve part of the problem. It can show you how to form valid arguments. For the truth of the premises, you need more information coming from other parts of and different branches of science. Now, coming back to what we discussed, as I told you, and I will repeat that during our course. In logic, we have terms. With the terms, we form sentences, and with the sentences, we form arguments. If we want to study logic, of course, we study the laws of reasoning, and then we start modest with the term, and then we arrive to something more complex, and that is the argument. Now, the notion or the term. The notion is the most simple logical form that represents an object that we know something about. So an object can be a material object like the microphone I am speaking to you now and I'm using to record this lecture, or it can be the so-called ideal object that does not have a material, how should I say, content attached to it, like the number 2. You cannot touch number 2, isn't it? And this is also an observation I would dare to make for those of you who are more inclined to the philosophical implications. There are very interesting objects in the reality surrounding us, isn't it? There are objects like, as I told you, the mouse, the computer, the microphone that you can analyze and you can simply access through your perceptions. But there are those very complex realities and objects like the inferences in mathematics and mathematical theories that are not so easy to grasp, and you need more than your simple perception to determine their truth value. And there are also those very particular objects like friendship, marriage, love, money, that come from this very interesting social reality. They do not have, if you think, for instance, of a term like honesty or friendship or correctness, they are not material, they are ideal. At the same time, they possess a meaning or even an existence in relation to us, to humans. It is very interesting, and philosophers have paid a great deal of attention to questions like, will honesty still exist if we as humanity all perish in a catastrophe, say a nuclear war, not so unlikely lately, or maybe a catastrophe happens, a plague, disease that destroys all humanity, will honesty still exist? I think it's worth wondering whether concepts like honesty would, or even God will still exist, or are they related to us? I mean, huge debates in philosophy, theology are expressed in books and movies, and the question is still out there for debate. Now, coming back to what we were discussing, well, what is the structure of the term? The structure of the term is the following. The term has a content, and the term has a sphere or a scope. The content of the term. What is the content of the term? Any element in the structure of the term that has the property from the sphere of the term. Oh, you may scratch your head and think, oh, this is complicated, but actually not. The sphere of the term, that is the object that have the property that form the content of the term. Let me explain. For instance, you have a term, yellow term. The sphere of the term, all the objects that are pen and that are yellow, right? Well, what is the content? The properties, being yellow and being a pen. Why do we say that they are inversely proportional? Well, think about it. Think of the following example. You have pen, that is object used for writing. So the sphere of this term is what? All objects in your reality, billions probably of objects, billions of objects that are used for writing. Okay, now the content of the term, the property used for writing. And now let me prove that they are inversely proportional. I say yellow thin pen. What did I do? I actually enlarged the content. I added more properties. If I add more properties and I make the content bigger, the sphere will become lower. Why? Because there are fewer objects in the surrounding reality that have all these properties, being thin and being yellow. And this is why we say that the sphere and the content are inversely proportional. Now, there are a few types of terms. We may have empty or non-empty terms. What do I mean by that? A notion is empty if its sphere does not contain any element. Now, we may have empirically empty terms like unicorn or fairy or all the characters in fairy tales, isn't it? They are terms, but they do not correspond to a reality. I mean, they seem to be naming a reality like the unicorn, but something like that has not yet been discovered. Or they can be logically empty, like the round square. What does the round square mean? It seems so impossible to grasp it with our minds. Now, we may also have individual or general notion. Individual notion or term refers to a single object, like the capital of Romania, Bucharest, isn't it? Or general, they refer to more than one object, number, human, student, pen, and so on and so forth. Then we may have collective or divisive terms. individually collective, they refer to a single collection of objects like the Leta forest from the Danube Delta, or generally collective like forest, library, army. You may see here that this type of collections do not refer to a particular collection, but to collection in general. A notion is divisive if it is formed by objects that are selected one by one because they have the same properties: pencils, geometrical form, prime numbers, or yellow pencils. These are examples of divisive notions. Now, we may also have precise notions or vague notions. A notion or a term is precise if we can say that an object is part of its sphere with certainty. If not, the notion is vague. For instance, square, rectangular. These are terms where we can determine with certainty if an object is square or rectangular, so if it belongs to this or not, to this class of square objects. But beautiful, old, these are terms that are vague because it is very difficult to establish whether a person is elderly, whether a person is beautiful or not, and it depends very much on the person. So these are vague terms. How can we determine whether term is vague and precise? It is a very easy way to do that. You may say something like, he is old enough, but you can never say, this is rectangular enough. It is either rectangular or not. Now, we also have terms that are abstract notions or content notions. We may use the content of the term as a criterion of classification. And in this particular classification, in this particular way of classifying notions or terms, we have abstract notions and concrete notions. A notion or a term is abstract if it represents an abstract property. For instance, courage is important in this mission. Might be abstract, but if you say the courage of this person, the courage of Vasile is fantastic, then the courage of Vasile is a concrete notion because it refers and it is ascribed to a particular person. It is not a notion that we ascribe in general to a number of unspecified objects. We also might have absolute and relative notion. A notion is absolute if it represents properties that belong to object, if those objects are considered separately, for instance, chair, bottle, or cup. A notion is relative if it expresses relations like father, companion, spouse, synonym, and so on and so forth. When I say my cup of tea, it is important to know that this is not a relation. I'm referring to a particular object. But if I say my daughter, well, this is a term expressing a relation. Okay, so we also might have independent notions and codependent notion. A notion is independent if it does not imply another, for instance, book or pencil. But we also have dependent notions like cause and effect, positive and negative. We also might have positive and negative notions or terms. A positive notion expresses the presence of a property, for instance, red pen, or a negative notion expresses the absence of a property, like in the example, black eye. Now, we have very important relations between notions. Three of them are basic. The identity, when the spheres of the two terms coincide. Woman, this is quite controversial. You might ignore it. I am just giving it because traditionally we might say that the dictionary definition of woman is adult human female, or you may pick another example. You have in Romanian synonyms, as usually the synonyms in the dictionary are uncontroversially terms that are identical. Also, the inclusion, like you have in the case of human and living entity. What do you observe in this particular example? The objects in the sphere of notion A, that is human, are included in the sphere of notion B, that is living entity. And also intersection, like students and athlete. There are common elements in the sphere of notion A and notion B, meaning that some students are athletes and some athletes are students. Then we have contrary notions. The relations to be found between the notions are species of a genre. What does it mean? Well, you have here this example. You have red, yellow, blue. These fundamental colors. And these are species of a certain type of color, fundamental color, right? But what it is important for the contrary notions. When, for instance, you use those to form sentences and to ascribe it to a certain object, say a red pen or yellow pen, you are in the position, if you use these sentences, the situation is the following. These sentences cannot be simultaneously true, but they can be false. A pen cannot be red and yellow at the same time, but a pen can be blue, right? So the idea is that it is important to notice the contrary notions refer to this situation where the sentences can not be true, but they can be false. So the object that we ascribe this property to cannot be both in this particular area, red, or in this particular area, yellow. But it can be blue, it can be somewhere else, so the sentences can be false at the same time. Now, the contradiction relation, this is clear even number and odd number. It is important to notice that usually the contradiction relation applies to abstract terms, usually in science or mathematics, like I gave this example, even number or odd number. If you say today, for instance, men and women, you will find yourself in a very heated and interesting and challenging debate. I urge you to follow it because it's very interesting. And nowadays, people are pushing for blurring the boundaries between the two. So you cannot put people in these two categories anymore because there is a debate about this contradiction relation and about the idea of putting people into mutually exclusive classes, right? So you have the class of humans and you have here women and men. This is no longer the case, and it is very difficult when you deal to social realities and social concepts to have this this division. But in terms of very precise and very concrete notions like even number or odd number, you may use it and you have this contradiction relation. So this is basically it. The logical principles, the types of terms and relations between terms. And this is the first course for today.